All right, good day, everybody. Welcome to another YouTube lessons. I'll be looking at chemistry, and I'll be looking at how to identify atoms and the number of protons, number of electrons, the number of neutrons, and the atomic number, the mass number. I want to tell you what those stand for. For those of us in beginner level chemistry, I'll just do a brief intro, and I'll explain the concept of isotopy, isobarism, isoelectronic species, isotones, and isodiaphers. So quickly, let's dive into the video right away. Now, for atoms are actually particles, or the smallest particles of an element which normally takes part in a chemical reaction. Yeah, smallest particle of an element which normally takes part in a chemical reaction. So atoms, they basically um, are represented with symbols, and the first scientist to suggest atoms of elements should be given symbol is J.J. Berzelius in 1814. Now, J.J. Berzelius in 1814. Now, if this is an atom A and Z, let me explain what I mean. Now, like hydrogen, the simplest atom, which is called protium, 1 1. Now, what does A stand for? Our beginners. So A stands for mass or nuclear number. Yes, A stands for mass or nuclear number. A can be atomic mass. They are two different things. Atomic mass and mass number are two different things. Atomic mass is the mass of an atom. It's usually given in AMU. Yeah, so A can be atomic mass, but basically, let's look at numbers for now. So A means atomic number. A stands for mass number, or I said nuclear number. It is the sum of the major particles in the nucleus. So the sum of the major particles in the nucleus. So nuclear number. Now, what does Z stand for? Z stands for atomic number. Yes, Z is atomic number. Z is also the number of protons. Yes, Z is proton number. And now, sometimes there's usually charge present. J is charge. J is charge. Now, I'll quickly say something. For elements without charge, they are said to be neutral, so they are charged. Or there's no, assuming I had the +1, that is charge, so the charge is +1. So because there's no charge on this atom, J is regarded or given to be 0. As simple as it is. So quickly, what about the number of neutrons? The number of neutrons. The number of neutrons, don't forget this, number of neutrons, which are neutral particles in the nucleus of the atom, because this atom usually is, according to many models of atom, the atom is given to be spherical in shape, with nucleus at the middle, electrons moving in cloud in the modern wave mechanics theory. So electrons moving in cloud around the nucleus. So the particles in the nucleus are numerous. For modern study or modern research has showed they are numerous, but majorly we still have the proton, the neutron, the mesons. But protons are positively charged, neutrons are neutral. So to get the number of neutrons in that atom, neutrons are is A minus Z. As simple as so, the number of neutrons in this atom should be 1 minus 1, which makes it so the number of neutrons here is 0. A minus Z. So how many protons are there? Z is proton 1. How many? What is the atomic number? 1. What is the? Sorry, pardon me. The atomic number is 1. The mass number is also 1. Now, how do you get the number of electrons? The number of electrons. So electron numbers is equal to Z minus J. So you just take Z, which is the atomic number, minus the charge. So 1 minus the charge. So the charge here is 0 because it has no charge. So 1 minus the charge, the electron number is 0. So let's watch some examples. Let's watch some examples. So now typical examples such as Na2311. So typical examples such as Na2311 23 11, Na 23 11, Na 23 11. So I can say an example such as Na 23 11. So let's say, what is Z? So remember, X, A, Z, J. Okay, so Z, which is proton number, is 11. So the number of protons here, there are 11 protons in this sodium atom. 11. Now, what about the number of electrons? What about the number of electrons? Now, the charge is 0, so there are no charge. So 11 minus 0 makes it 11. What about the number of neutrons? The number of neutrons is equal to A minus Z. A minus Z. If you don't have that, take the video back. You see what we did. A minus Z. So mass number minus proton number, or nuclear number minus proton number, nuclear number minus atomic number, you get neutron number. So 23 minus 11 gives me 12. So trying others. Now let me quickly try for let me try a simple one for let's use a charge species. Ca2 plus 40 20. Yes, Ca2 plus 20. So the proton here is 20. Z. Atomic number is 20. Neutron is A minus Z. 40 minus 20, that's making it 20. Now to get the electron, it is 11 minus charge, or rather Z minus J. Z minus J, that means 20 minus charge. So 20 minus plus 2, so that should be 18. So there are 18 electrons there. 18 electrons. So I'll put some questions. Some problems normally come in this form. They will ask you to get the number, or to get the symbol of the atom. They will ask you to get the symbol of the atom, and they'll give you the number of protons, neutrons, and electrons present. So we'll try some. So let me try one like that, so you see it. So you see, given, let's take it, given an atom have 11 protons, given an atom have 11 protons, so protons is 11, 12 electrons, and 14 neutrons. Check it here. And 14 neutrons. What is the symbol? What is the symbol? So you see options. Let's take some options. X12, S12, S12, 25, B, S13, 25 plus 1, or just plus, C, X, X11, 25 minus D, X11, 26 minus. So the question can come like this. What is the symbol of this atom with 11 protons, 12 neutrons, 12 electrons, and 14 neutrons? Now, how do we quickly get the symbol of this atom? So I'm going to quickly solve here. I'll work here. I'll work there. Let's say we have X as a symbol, as the option takes it to be. Let's say we have X as a symbol, as the option takes it to be. Yeah, we have X as a symbol, as the option takes it to be. Okay, now, what is usually Z? What is usually Z? Because I place it like Z, A, J. What is Z? Please take note. Z is the number, please don't forget this. Z is the atomic number, or the proton number. So 11 is proton. Take the video back in case you have forgotten. Z is the proton number. So when writing the symbol, Z is the proton number. Okay, now Z will now be 11 because there are 11 protons. What is the electron number? The electron number is 12. So since electrons are more than proton, there is charge. Please take note of that. Please note this. If electron is more than proton, there's charge. If proton is also more than electron, there's charge. But if electrons are more than proton, the charge is negative. If protons are more than electrons, the charge is positive. Now ask, who is more? Electrons are more than protons. With how many? There are 12 electrons, there are 11 protons. 12 electrons, 11 protons. It means the electrons are more with one. So it is a negative charge. So how many negative charge? Just a negative charge. Just one, because electrons are more than protons, just one. Yes. What about the mass number? We said the mass number, the neutron number, neutron is equals to A minus Z. That means A, which is mass number, minus Z is equal to neutron. Neutron is equal to A minus Z. We said that earlier. A minus Z is neutron. A minus Z is neutron. So how do we quickly get A, which is the mass number? We have Z to be proton number already, 11. So neutron is already given. So to just make A, substitute the formula, A is going to be neutron plus Z. So to get A, I have number of neutrons 14 plus Z, which is the proton number. So 14 plus 11 is going to be 25. So we have 25, 11. So this becomes the symbol of the atom. So this makes it option C. This is how we tackle it from scratch. We tackle it lithium by lithium. That's how to tackle it lithium by lithium. Lithium by lithium. Now, what are isotopes? Now, isotopes are actually atoms. Isotopes are atoms with the same atomic number but different mass number. So let's say we have X 11 11 and here is 25 24. So the masses or the nuclear numbers are different, but the atomic number are same. So basically they are usually atoms with the same number of protons. Please take note. Isotopic difference. The reason why isotopes are different is because they have different numbers of neutrons. What do I mean? So how many protons are here? 11. How many protons are here? 11. How many electrons are here? 11. They are no charge. 11 minus 0. 11 minus 0. They are no charge. But the neutrons here is going to be 25 minus 11, making it 14. 24 minus 11 makes it what? 13. So the difference in isotopic difference is due to what's called now difference in neutron. The concept of isotopy was first looked about by Frederick Soddy, but W. Aston properly defined it and explained it 1 year later, and Aston also gave us an instrument used to measure isotopic mass. So when two isotopes they have different masses, we can detect their different masses using an Aston instrument, or what is today called a mass spectrometer, which is used to analyze to get the structural elucidation of some compounds, and even to get the elemental composition in organic chemistry. For that's isotopes. There are a lot of isotopes. Another type of a common isotope in nature is chlorine 17, chlorine 35, 17, and chlorine 37. Chlorine 37 and chlorine 35 is an example, typical example. This is chlorine 37. Please take note. Chlorine 37 and chlorine 35. 35, 37, 17, 35, 17. So they are examples of isotopes. There are common example, carbon 12 and carbon 14. They all have the same mass number, which is 6, but 12 is the mass of the first carbon, 13 is the mass of the second one. They also what we call carbon 14, which is using radiocarbon dating to determine the age of fossils. Now, those are isotopes. Quickly, let me talk about isobars. Isobars is more like the opposite, but not really opposite. Isobars are not atoms. Usually, they are of different elements. So, isobars are usually atoms of different elements with the same mass number. So mass number can be 25 20 y 25, but the atomic number here will be 17, here will be 15. So they have the same mass number but different atomic number. These are isobars. Same mass number, same nucleon number, but different atomic number. Example in chemistry is calcium 39 40, potassium 39 40, pardon, calcium 39, 20, potassium 39, 19, argon 39, 18. Now 20, 19, 18 are the atomic number, but the mass number is 39. It's constant. Those are isobars. What are isotones? Isotones are atoms with the same neutron number. So when two atoms have the same neutron number, they are said to be isotones. They are isotones. Now look at it. See isotones. So isotones. Now see examples of isotone, the same neutron number. Let's use calcium, for instance. Calcium 20, calcium 40, 20, calcium 40, 20, calcium 40, not calcium 39 in this case. We are using calcium 40 and calcium and potassium 39, which we used earlier, and 19. Yes. So what is the number of neutron here? The number of neutron here is 20. The number of neutron here is also 20. So because they have the same numbers of neutron, they are said to be isotones. Isotones have the same number of neutron. They have different number of electrons. Electrons here is 20, electron here is 9, because there are no charge. 20 minus 0, 19 minus 0. So 20, 19. Proton here is also 20, 19. But basically, they have the same neutron number. They are said to be isotones. Now, quickly, I'll talk about isodiaphers, which is similar to isotones. Now, isodiaphers, I will write for isodiaphers. Isodiaphers have same neutron defect. What is neutron defect? Same neutron defect. What is neutron defect? Neutron defect is equal to numbers of neutron minus numbers of proton. So neutron defect is the numbers of neutron minus numbers of proton. When the numbers of neutron and numbers of proton, when you subtract them, it was all called neutron defect. When two atoms have the same neutron defect, they are called isodiaphers. There are two isodiaphers in chemistry, or there's just one example of isodiaphers in chemistry. There are two atoms that are isodiaphers to each other. So one of them is uranium, the other one is thorium. So uranium 234 92 and thorium 23. So sorry, pardon me. Uranium 238 92 and thorium 234 90. Thorium 234 90. Let's quickly check it out. So the number of protons here for thorium is number of protons here is 92. The number of neutrons here is 238 minus 92. 238 minus 92. All right. The number of neutrons is 146 on calculating. So 238 minus 92 will give me 146. Let me confirm that again. 238 minus 92, again 146. So 146. The number of protons here is 90. Number of protons here is 90. Number of neutron here, A minus Z, 234 minus 90. 234 minus 90, 234 minus 90, you get 144. 144. 144. So what's neutron defect? Neutron defect is number of neutron minus number of proton. So if you subtract this neutron minus this proton, this neutron minus this proton, you get the same value. So let's see. 146 minus 92. 146 minus 92. That should be 54. 54. 144 minus 90, that's also 54. So the number of neutron defects on both sides are same. So these are the only two atoms that have the same neutron defect in chemistry. So they are said to be isodiaphers. Until I come your way next, I remind the analogous. Please make sure you watch this video. Share with your friends. It is helpful. Share to them, help them, especially those of them about to prepare for their exam, O-level exams, A-level exams, or lack the foundation. Share these videos with them. Like the videos, subscribe. It tells the algorithm that it is helpful to people, and we should do more. So I will see you guys when I see you next. God bless you all.